Hello and welcome back to the next section, where we'll dive deep into the advanced useReducer hook. This special hook gives us another powerful way of managing state. And since state is super important in React, useReducer is a super important hook. And it's also important to master it in order to later understand Redux. So that's why I dedicated an entire section to the useReducer hook. Now this section does run pretty long, but that's because we're going to use useReducer to build this entire new project, reinforcing all the other skills that you have already learned so far. So if you're looking to save some time, you only need to watch like the first 5 or 6 videos in this section. And with that being said, let's now jump right in. Let's start this section by getting a first high-level overview of how to use the useReducer hook in practice over this lecture and the next one. And as always, it is time to create yet another project. So let's move to our folder. And then let's run npx create React app at version 5. And then the app that we're going to build in this section is going to be called React Quiz. All right. And now let's wait until create React app finishes installing all the packages that we need. Okay. And now it's time for our usual cleanup. So first, I'm going to rename this here. So we're already in our 10th project. And now let's get rid of all this stuff here as always. Okay, then getting our starters from here. And this time we have 5 starter files. So I think that might be a record. Then yes, replace the CSS file. And then let's just drag and drop our folder onto VS Code. And then, as always, let's also delete all the stuff we don't need from here. And the rest is okay. So we need the app component and we need to include the CSS file, which as always is part of the starter files right here. So let's start by opening up the app file and the date count file, which we will need soon. And then here, let's delete everything and start the app component from scratch. So export default function app. And then here, let's just create a div. And in this div, I will immediately call the date counter component. So date counter, and then I need to import that. From date counter. So let's take a look. So opening up our integrated terminal and then npm start. And so this is what you should see if you successfully started your application. So let's also close the app, because in these first 2 lectures, we will only be working with the date counter. So this date counter is identical to what we implemented in one of the previous challenges. So basically here, as we click on one of these values, it will then increase the date. We can also update that number here, and you see that then it also increases the date. And we can change the value on the slider, which is basically the step. So if we then click here, it increments by whatever the step value is here. Okay, and so what we're going to do now is to basically replace these 2 useState hooks with useReducer hooks. So it's very important that you understand exactly what this code here does and how it works. And so in case you didn't do the challenge or don't really remember, then please take a few minutes now to really check out this code. So all the event handlers that we have here and how they update these two states and how the states interact with one another. So only proceed in this lecture once you are really sure how everything works here. Okay? But anyway, let's now finally talk about the useReducer hook. So the useReducer hook is basically a more advanced and more complex way of managing state instead of the useState hook. Now the useReducer hook works with a so-called reducer function, which is a pure function that will always take in the previous state and the so-called action as an argument and will then return the next state. But instead of talking about it, let's actually use it. And I will start by replacing this first count state right here. So let's write, again, count, and then dispatch, and I will explain what these mean here in a minute. And so then use reducer, and so this hook takes in not only the initial state, but also the reducer function that I was just talking about. So let's already write that here, and I will then create this function in a minute. So that's the first argument, and the second argument is again the initial state. And so that's again 0. So let's then comment out this state, and then let's create outside of the component that reducer function. So that's just function reducer. And so as I was saying, this reducer function takes as the arguments the current state and an action. And so the first thing that we're going to do is to just log these two to the console. Okay. Now here we got a couple of errors. So let's just comment out all of this code here. So we actually no longer need any of this. And then we also need to include the useReducer hook into our application. Okay, let's maybe reload here. And there we go. Okay, so we have our reducer function, but when does this function actually get called? Well, that's where this dispatch here actually comes into play. So we see that the useReducer hook does return the current state, so just like the useState hook, but then instead of also returning a state updating function, the useReducer hook returns as a second thing this dispatch function. And so this dispatch function can also be used to update the state. It just works in a slightly different way. So let's just call this function right here. And then let's pass in the number 1. And actually let's do that in the increment event handler. So the one that is going to be called when we click here on this button. So let's actually click on this button, and here we get our output. Let's make this a bit bigger. And so the output that we get, so the console.log from here is 0 and 1, meaning that the state is 0 and the action is 1. So why is that? Well, it is because the reducer function gets access to the current state, as I was saying in the beginning, which right now is 0. So it's this initial state. And then it also gets access to the action, which right now is simply this one that we passed into the dispatch function. So this is basically going to become the action in the reducer. And so the idea of the reducer is to take these two things, so the current state plus the action, and based on that, return the next state. And so let's do that. So all we want to do is to return the state plus the action in this case. And so whatever we return here will then become the new state. And so this means that right now our value here should become 1. Let's just reload. And there we go. So our state was indeed successfully updated. Now when we click here, of course, nothing's going to happen, but let's fix that. So let's then again call the dispatch function, which in the terms of useReducer, we call dispatching an action. So here we will dispatch an action of -1. And so then that -1 will get added to the current state, which will then decrease the value. And so that works just fine. Great. Now, at this point, this isn't really useful, is it? I mean, we had to do a lot of additional work to get the same functionality as just this, right? But trust me, it will get a lot more useful as we keep going here. So next up, let's think about how we can set the state. Because remember, when we type some number here, we actually want the state to update to that number. So that's what we have here in the define count. However, this is not going to work really in the same way that we have been doing. So here, if we just dispatch e.target.value, then that will simply be added to the current state, right? So let's write something here. And I will now write a 0 so that we then have 10 here. But then as I wrote the 0, it actually added that to the state because, well, here we are just adding the action to the current state. And so if I now write another 0, that will just get added to the state that is already here as well. So that's not at all what we want. And so therefore, now it's time to actually start thinking about actions here. So basically, in this case, we have 3 actions. We have decreasing the count, we have increasing it, and we have setting it. And so we should actually name these actions. So what we're going to do is to not just pass in this value, but an object which contains the action as well as this value. So let's write type, and then let's call this dec for decreasing, and payload, and then set it to 1. Okay. So this object is what we now call an action when we work with reducer functions. And in theory, this object here could have any shape that we wanted, but it is kind of a standard to always just have the type property and the payload property. So actually not playload, but really payload. So this is the standard that you will always see when using the useReducer hook, and the same is actually true later in Redux. So in case you heard of that. So let's do the same thing here as well. So type, this one will be inc, and then the payload here will just be 1. Okay, and so now here, instead of just doing this, we now need to account for these different types. So let's say if the action.type is inc, well, then return the current state plus action.payload. Then if it is decrease, then minus. And if the action.type is set count, which we will create later, well, then actually simply return action.payload. But let's experiment now with this so that it makes more sense. So let's reload. And first of all, let's see if this works now. And beautiful. So really nice. And now here, let's dispatch also actually an action object with the type of set count. And then here the payload will be whatever value is typed into this field. And so now this actually works. So whatever value I type here now is this e.target.value, and this will become the payload in this action right here. And so then we dispatch this action to our reducer, And so then that action contains that value, so this 700 right here, and the type. And so then, based on that type, we decide that the next state should become exactly that value. So that's 700 in this case. And if all this sounds and looks really confusing, then please don't worry at this point. So now we are only getting like an overview of how all this works in practice, but I will explain you exactly what the useReducer hook is, how it really works, and yeah, we will have some nice diagrams, and hopefully by then all of this will make a lot of sense. Now, just to finish here, let's think a little bit more about this. So actually, is there a need to pass in the payload right here and right here? Well, not really, because the reducer should actually know itself what happens when we want to decrease. Right? So decreasing and increasing is really just adding or subtracting 1. And so we should add that logic here directly in our reducer. So our reducer should know by himself or by itself how to perform these types of actions. And so then we can remove the payload from here and make it a little bit easier to dispatch this action. So the payload property here is optional. And of course, here in this case, we still need it. So we basically still need to pass our reducer this value here, because otherwise, of course, it would have no way of setting the next state. Okay, and so this still works. And with this, we finished the first part of transforming this count state here from a simple use state to a use reducer. And so let's quickly recap what happened here. So this new hook takes in not only the initial state, which was 0, but also a reducer function, which will always get access to the current state and the action that we pass into the dispatch function. So where does this dispatch function come from? Well, it is one of the things that useReducer returns. So this returns always the current state, which here we decided to call count, and then it also returns the dispatch function, which we can then use to dispatch actions like this one. So the convention is to dispatch actions that contain a type, and then optionally also a payload, with the goal to pass in some value into the reducer. And so then our reducer function takes the current state and it takes all the information that is contained in the action in order to compute the next state. So usually based on the action type, the reducer then takes some kind of decision. For example, if it's inc, so increment, then it simply adds 1. If it's decrement, then it subtracts 1 from the current state. And if it's set count, then it will simply set the new state as the value that came in as the payload. And so those values are returned. And so this returned value is what will become the next state. And so then, as always, the component is re-rendered and the UI is updated as well. Okay, so hopefully this made a bit of sense, but if not, well, we will have lots of opportunities to practice this throughout this section and the rest of the course. Next up, we will also incorporate this step here into our reducer. And so let's do that in the next video right away. Welcome back. So let's now also incorporate the step state into the reducer that we have been building. So usually we use reducers when we have some more complex state to manage. So not just one single value as we have been doing here. So what this means is that usually the state is going to be an object and not just one single value. So let's now comment out this here as well. And then let's define an object called initial state. And this again is a pretty common name. And so here, let's define our count as 0 and then the step as 1. So exactly the same default values that we had before. And then here we will now pass in that initial state instead of just the 0. And then here, now our state will no longer be called count, but, well, let's call it just state. And we could also immediately destructure that state object there, but let's do that here. So let's say count and step destructuring from state. And so now again we have these functions here that we had before, which now no longer exist. Okay, and now also what we have here is not going to make a lot of sense anymore. And so let's just go back for now to our console.log here. Also don't need this anymore. And so let's just quickly reload and click on one of these buttons here, which will then dispatch an action. And here we have our first problem for some reason. Maybe we actually need to return something from there, but let's just try that again. Yeah, so that doesn't really work. So let's just try to return some object from there. So you maybe don't have to even do this. So this is just to avoid that error. And so yeah, now that works. So all I wanted to do here is to now show you the state and the action again. So the state that we now get in the reducer is the same as this initial step that we passed into useReducer. And so then we need to return an object with the same shape. So it also contains the count and the step. And so let's now adapt our reducer function here for that. Now, actually, it is very common to use a switch statement inside of a reducer function like this. So instead of multiple ifs, we just do usually a switch. And the value that we want to evaluate is, of course, the action.type. And then we just do one case for, well, all the possible cases that we can have. So what do we want to return in the case that the action type is decrease? Well, before we were just returning the state plus 1. But now we can no longer do that. So now we need to return an object with this shape. Remember? So how do we do that? Well, first of all, let's set the count based on state.count plus 1. And then we also need to set the step. But instead of writing it out explicitly, what we do is to spread out the entire current state object here. And then with this part here, we basically overwrite the count property there. And so this is exactly the way that we have been updating objects in the past as well. So basically creating a brand new object which contains all the information of the previous object and then whatever we want to overwrite. Now here I'm getting this warning because we need also a default. And so here, in case we basically get an action that is not recognized by our switch, we just throw a new error which says unknown action. Well, this is still not happy, but well, let's just keep going here for now. So don't really see what the problem there is. So let's do the other case as well. So to increment is -1. And the error is still not disappearing. But the reason for that is that here we are already returning. And so then this code here would be unreachable. Okay, and finally we have this other set count case. So here I'm basically just converting the code that we already had into a switch statement and also to returning an object with the shape, again, of count and step. All right, so spreading out the state, and then the count will be equal to action.payload. Okay, so for now this is going to work exactly the same way as before. except that I did switch here. So here it is the plus and here the minus. So let's, yeah, now that works. And if I type here, then that also updates the state. Great. And now let's actually do the same thing here for the step. So here we now also want to dispatch an action with the type of set step, right? And the payload is going to be exactly the same. So again, we convert to a number e.target.value. Okay, so set step. And so now here we need to then add a new case for that. And so in this case, we want to return the entire state and set the step this time to action.payload. So that's state. Let's reload. And yeah, beautiful. That works. And so now the only thing that we have to do is to actually take this step here into account when we increase and decrease here. So that's easy enough. So that's just state.step. And then here, of course, the same thing. And so now this should become 2, yes, 8, and so on and so forth. Now, okay, let's just get rid of this here. And well, up until this point, maybe all of this still doesn't seem so interesting. So everything that we did so far could easily have been achieved with the use state hooks as well, right? But now let's actually do something different. Also get rid of these here. Okay. So as I was saying, let's do something different. So, which is this reset function. So what we did before was to simply take the two state setters and then call both of them. But now we can do one big state transition, which does all that at the same time. And so that's going to be one of the huge advantages of the use reducer hook. So especially, of course, if we had even more states than just these two. So let me show what I mean in practice. So here we can just dispatch an action with the type, for example, reset. And here we don't need to pass any data into the reducer, and therefore we don't need to specify the payload, because we can do that right inside the reducer function. So let's then add that case here as well. So reset. And so then here, all we need to do is to return a new object where the count is reset to 0 and the step is reset to 1. And so here we can essentially update these two pieces of state at the same time. And we can do even better. Let's cut this from here. So this can actually live outside. And then here we can just return the initial state. All right, and so if I click on reset, then bam, there we go. So our entire state just got reset to its initial state. So all in one go, just with one dispatch right here. So all we're doing here actually in these event handlers is to just dispatch. And so we could just move all of these dispatches then here right into the JSX. So that would actually make a lot of sense, but I won't do that right now. But yeah, we could just replace all these event handlers that we have here, because all of them, all they do is to dispatch actions. The logic itself, so the real logic of what they do, is now all centralized in this one reducer function. And so that is the beauty and the big advantage of the reducer function. So Basically, we have all the possible state updates that can happen in our application in this one central place here. And so this makes it really easy to understand the entire application without having to go into all the different components and all the different functions. I mean, of course, here we only have one component and it's all really simple, but maybe you can start seeing how nice this can be in a bigger application. And in fact, we will see that in action once we start building the big application for this section. But all these advantages will become more clear later on. For now, in these two lectures, I just wanted to focus on the mechanics of the useReducer hooks, so really how it works, and especially how this reducer function here works. But I know that this all looks very confusing right now, because I perfectly remember how I felt when I first learned about this quite complex hook. But since we are in the advanced React part now, it's time to learn about these more difficult things. But anyway, in the next lecture, we will have some nice diagrams that will really illustrate the flow of the data and of the state here. And so stay tuned for that. So we just learned how to use the useReducer hook to centralize all the state updating logic in one central place, which is the reducer function. So let's now dive deeper into the concept of reducers and how and why they can make our applications a lot better in certain situations. So up until this point, we have been using the useState hook to manage all our state, right? However, as components and state updates become more complex, using useState to manage all state is, in certain situations, not enough. For example, some components have a lot of state variables and also a lot of state updates that are spread across multiple event handlers all over the component, or maybe even multiple components. And so this can quickly become overwhelming and hard to manage. It's also very common that multiple state updates need to happen at the same time, so as a reaction to the same event. For example, when we want to start a game, we might have to set the score to 0, set an isPlaying status, and start a timer. And finally, many times updating one piece of state depends on one or more other pieces of state, which can also become challenging when there is a lot of state. And so, in all these cases, useReducer can really help. So these are the problems that reducers try to solve, and so let's now see how. So first of all, useReducer is an alternative way of setting and managing state, which is ideal for complex state and for related pieces of state. Now, we already used useReducer in the last two lectures, and this is what that looked like. So we call useReducer with a reducer function and its initial state, and it returns a state and a dispatch function. So, starting from the beginning, when we use useReducer, we usually store related pieces of state in a state object that is returned from the useReducer hook. Now, it could also be a primitive value, but usually we use objects. Now, as we already know, useReducer needs something called a reducer function in order to work. So this function is where we place all the logic that will be responsible for updating the state. And moving all state updating logic from event handlers into this one central place allows us to completely decouple state logic from the component itself, which makes our components so much cleaner and so much more readable. So when we manage state with useReducer, it's ultimately this reducer function that will be updating the state object. So in a way, it's a bit like the setState function in useState, but with superpowers. Now, in practice, the reducer is simply a function that takes in the current state and an action, and based on those values, returns the next state, so the updated state. Now keep in mind that state is immutable in React. This means that the reducer is not allowed to mutate the state. And in fact, no side effects are allowed in the reducer at all. So a reducer must be a pure function that always returns a new state. And again, based on the current state and the received action. And speaking of the action is simply an object that describes how state should be updated. It usually contains an action type and a so-called payload, which is basically input data. And it's based on this action type and payload that the reducer will then determine how exactly to create the next state. And now the final piece of the puzzle is this. How do we actually trigger a state update? Well, that's where the dispatch function comes into play. So useReducer will return a so-called dispatch function, which is a function that we can use to trigger state updates. So instead of using setState to update state, we now use the dispatch function in order to send an action from the event handler where we're calling dispatch to the reducer. And as we already know, the reducer will then use this action to compute the next state. Okay, so these are all the pieces that need to fit together in order to effectively use the useReducer hook. So an action object, a dispatch function, a reducer, and a state object. But now let's also look at a diagram to really see how all of these pieces actually fit together in order to update state. So let's say that we're in an event handler in some component, and we now need to update some state. So what do? Well, that's right. We called the dispatch function that we got back from useReducer in order to dispatch an action to the reducer. And this action, as we learned before, is an object that contains information for the reducer. So information about how the reducer should update the state. In this case, the action type is update day and the payload is 23, which probably means that the reducer will set the day state to 23. Now the object doesn't need to have this exact shape with a type in the payload, but it's a standard that has been adopted by most developers. Now, basically, the reducer takes in this action together with the current state, and it will then return a brand new state object, which we usually call the next state in the context of reducers. And as always with state, updating state will then trigger a re-render of the component instance. Now, if you're wondering why the reducer function is actually called a reducer, the answer is that it's because it follows the exact same idea as the array_reduce method. So just like the reduce method accumulates all array values into one single value, the React reducer accumulates all actions into one single state over time. Okay, now behind the scenes, the dispatch function has access to the reducer because we passed it into the useReducer hook, right? So dispatch is really coordinating this whole thing and also giving the reducer access to the current state. And now, to understand this even better, let's compare the mechanism of useReducer with the much simpler useState mechanism. So when we use useState, we get back a setter function. And let's just call it setState. And then, when we want to update state, we just pass the new updated state value that we want, and React will simply update the state, which in turn will trigger the re-render. So it's a lot simpler and more straightforward than useReducer. But since useReducer solves the problems that we saw earlier in this lecture, it's a great choice in many situations, even though it's a bit more complicated to set up. But we will talk more about the big advantages of useReducer and also when to use it later in the section. Now, I understand that this whole idea of dispatching actions and writing reducers is super confusing in the beginning. I know because I do remember how confused I was back in the day. And so let me show you now a really helpful analogy that made all this really clear to me when I first learned about this. So, imagine that you needed to take $5,000 out of your bank account for some reason. Now, since this is a large amount, you can't just do it from an ATM. So, you need to go physically to a bank. Now, once you're at the bank, how do you actually get those $5,000? Do you walk straight into the bank's vault, grab the cash, and then go home? Well, I don't think so, right? That's usually not how it works. How it does work is that you go into the bank, and there you'll find a person sitting at a desk ready to assist you. Now, when you arrive at the bank, you already know how much cash you want to withdraw and from what account number. And so you walk right to the person and tell them that you would like to withdraw $5,000 from account 923577, for example. What happens then is that usually the person will type something into his computer, check if you actually have the cash in your account, and if so, he goes to the bank's vault and gets the money to finally hand it over to you. It's your money after all, right? But note the big difference between this real version and the previous version of the story, where you just grabbed the cash yourself. In this real version, you told the person what to do and how to do it, and he then got the money for you on your behalf. And so you didn't take the money directly yourself. And that's a huge difference. So, does this maybe start to sound familiar? Well, I hope it does. And so let's now bring this analogy back to useReducer and identify what each of these pieces represents in the useReducer mechanism. And let's start with the most important thing, the state. So, what do you think the state is in this analogy? Well, the state is represented by the bank's vault, because this is where the relevant data, so the money, is stored and also updated. So the vault is what needs to be updated, and so that's our state. Nice. So with that out of the way, let's think about how the money is taken from the vault. So about how state is actually updated. So starting from the beginning, what do you think the customer going to the bank represents in this analogy? Well, the customer going to the bank and requesting the money is clearly the dispatcher, because it is who is requesting the state update, right? And they are doing so by going to the person and requesting to withdraw the $5,000. So, what is the reducer here and what is the action? Well, the reducer is going to be the person working at the bank, because that's the one who actually makes the update. In this case, it's the one who goes to the vault to get your money. But how does the person know how much money to take and from what account? They know because you told them so exactly in your request message. And so that request message is clearly the action. In this example, the action can be modeled like this, with the action type being withdraw and the payload being the data about the withdrawal that you want to make. So, summarizing, you went into the bank with a clear action in mind. You then dispatched that action to the reducer, so to the person working there, who took the action and followed the instructions to take the right amount of money from your account, so from state. He then gave you your money, finishing this cycle. So you did not go directly into the vault and took your money. Instead, you had the person as a middleman who knows a lot better than you how to perform different actions on the vault. So he knows how to deposit, how to withdraw, how to open and close an account, how to request a loan, and more. And he does all this without you having to worry about the details. So exactly like a reducer function, which also decouples and abstracts all the state updating logic away from you, so that you can have clean and easy to understand components. Okay, so I hope that this now made the relationship between dispatcher, reducer, action, and state crystal clear. And you will get plenty of opportunities throughout this section to practice all this. Let's start building a brand new app that will hopefully show you how extremely helpful the use reducer hook can be. And so this is the application that we are going to build, and it's called the React Quiz. So as the name says, this is basically a very simple quiz about some React concepts. So this starts by actually loading the questions from a fake API. And so at this point, we have received those 15 questions. And so then we can start the quiz right here. So here then we have the question with the 4 different options. And up here we can see our progress and the number of points that we have won so far. So here then we can, of course, click on the correct option. In this case, React is the most popular framework. And so then immediately it is marked as correct. And also the next button here appears so that we can move to the next one. And now this time let's choose a wrong option. And so, of course, the correct one is still marked here as correct. Now, of course, I will not go through the entire quiz here, but we will see what the end result, so when we reach the end of the quiz, looks like. Now, just notice that here we also have a timer running. And so when this timer finishes, then we automatically lose, or we actually finish the quiz by then automatically. And we only get the points that we have gathered up until that point. So all the state that we see here on the screen, so which question was selected, the number of points, which question we are right now, the timer, and really all the state is just managed by one big reducer, because that's what this section is all about, right? Now in this lecture, all I want to do is to just set up here the app skeleton. So basically just setting up the structure with the header and the app itself. And so then in the next lecture, we can start fetching the questions and start building the application. So we no longer need this component here. And instead, let's come back to app. And here we then remove that date counter. Okay. So our parent div here will have the class name of app. And then inside that app, we will have a header. So basically this part here with the logo and the name of the application. Now, as I said in one of the previous sections, we will now start to actually create one file per component. So making this project development a bit more real world. Now, in case of the header, I actually already created that component for us. So it's just this very simple component that doesn't even have any logic or any state, and it doesn't even accept props. So it's just a very simple presentational component that has the image, so the logo, and the title. And so let's include that here, just like this. And of course, we then need to import that component from that file. So in the current folder, and then header. And there we go. So there we have our header, and then here below that, we will have basically the main content. And so for that main content, let's create a main component. And before we do that, I will just write the markup here. So let's say that we want a main element with the class actually of main as well. And then, for example, let's say we want a paragraph with the progress, let's say 1 of 15. So this is just some dummy content here. And then the question itself. Right? So let's say that we just have this. But we want it to be not inside the main HTML element here, but instead we want it to be inside its own component. So that then here our app component stays nice and clean. So just having like different components, but not these elements with their class names. So let's then create a new file with a new component. So this one will be called main.js because main will be the name of the component. And now let's actually, for the first time, use that snippet that I gave you at the very beginning of the course. So remember that. So let's come here to the user snippets, and then it should be one of these. Yeah, so the snippet that I mean is the RFC snippet. And if for some reason you didn't add this to your own snippets at the beginning of the course, then you can just maybe copy the code from here, or you can go back to that setup lecture at the beginning of the course. Because again, we will now use that snippet and it will be extremely handy. So all we have to write is RFC, hit enter, and bam, it creates a brand new component for us, even with the name of the file. So it got the name here from the file, and then it accordingly named the component. And so now all we have to do is to change right here or markup. Now here we want to change from a div to a main element. And so remember how many times it was quite annoying that we had to change this opening tag and the closing tag. And so to fix that, let's install this extension right here. So auto rename tag. So I already have it installed, but just go ahead and do that. And so then when I change this div to main, then you see that both of them change at the same time. So here the class name again of main. And now here, what will we place as the content? Well, basically here, we want this content to stay in this component. So we want to just pass it in to the main. And so for that, we use the children prop. Remember? So basically doing component composition here. We have done this multiple times already at this point, so this should be nothing new. And so with this, all we have to do is to replace this right here with main. And again, it then automatically replaced it here. And then all we have to do is import main from main. All right, now it looks the same here, but now we have a bit of a better structure. And also, I think the component tree is a lot more complete like this. Well, actually, this hasn't updated yet. Yeah, so then also in the tree, we can see that we have the app, a header, and a main part. Okay, so let's now set up a fake API on a fake web server and then use that to load the questions data into our application. So this time we're not going to use a real API because I created these questions myself. And so then there's no API with that. But I still want to basically pretend that we are loading these questions from somewhere. And so therefore we can create a fake API using an NPM package called JSON server. So let's come here to our terminal, create a new tab basically here. So with this, we keep this process here running. So the one that is running our app. And then here we have another terminal. Just make sure that we are in the correct folder. And then let's do npm install JSON server. And in the meantime, I'm going to get some data here from the starter data that I forgot to include at the beginning of this section. So when you copied the files, you probably already got this questions.json, But again, I did forget actually to place this file here earlier. So let's come here into React Quiz and paste this file here. Or actually what I want to do is to create a new folder out here. So let's call this folder data, and please make the same thing here in your file structure. So creating a new file there, and then let's move this questions.json file in there. Okay, so make sure you have that file in that folder. And in the meantime, this finished running the installation. And now what we need to do next in order to be able to call that package, so to run the JSON server command, we need to add a new npm script here to this file. So these npm scripts that we have right here are basically the commands that we write here. So each time that we write npm start, we are able to do that because here this start command exists. All right. And so let's now create our own npm script here with the name of server. And so what should happen here then is that we want to call, so we want to basically run the JSON server package, and we want to watch a certain file. And so that file is going to be our questions data. And actually, let's take a look at that data here. So basically, it is just one object with the questions property, and then that property has one array. And so then the array is our usual array of objects. So each object then has a question, the options, the correct one, and the number of points. And so this is the file that we now want to watch. So basically to create an API from. And so we just do data, which is the folder, and then questions.json. And finally, we also need to specify the port, let's say 8000. And that should be enough to get us going. So let's do npm run server. So here we need to run keyword. It's not just npm server, but npm run server. Okay, and so now we should have our API running. But somehow I see that here it's port 3000. So here it's probably all lowercase. So give that a save, close that here. So it was running basically before at the same URL, so in the same port as our React application. So let's reload that. Let's retry this. And yeah, now it is running on port 8000. And so we can just copy this URL, change this to 8000, and well, then we should see our data here. But apparently there was some problem. So let's see. Well, now it thinks that it is already in use. So let's maybe quit our other npm process here as well, and then run npm start again. And then here, let's run npm run server. Okay, that's still not working. So we can just change to any other port. So this doesn't really matter. So if for you it worked like this, then just go with that one and change the 8000 to 9000. And actually we also need to then add questions, which is basically the endpoint we are creating here. And it is called questions because that is the name here of this field. So if it was called like this, then here we would have to add these two S as well. So now this no longer works, and our data would be here in this URL. But of course, that doesn't make a lot of sense. So let's just use this. And also you notice that this is actually just the array. So here we see the array is exactly this one. So let's now grab this URL and then fetch it into our application. So we want to load that data on mount. And so for that, let's use our friend, the use effect hook. And as I mentioned, let's just run it on mount. So here we want to fetch now from this URL. And here let's actually not even bother with an async function, but let's just use the then method to handle this promise. So this will give us a response that we need to convert to JSON, which will then in turn return another promise. So we chain another then handler there. And so this should then give us our data. For now, let's just log that to the console then. And also let's catch a possible error here by also logging it to the console. Let's do console error here. And just like this. Okay. So let's actually try that. So let's reload, come to our console, and beautiful. Here is our data. But now, of course, we will at one point need to display that data here in the UI. And so for that, we are going to need state. And as you can imagine, we will now use the useReducer hook to create that state. So let's do that. So here we will get the state object and the dispatch function. Remember? And then we use our useReducer hook, which was then added here to the imports. And here we pass the initial state, which we don't have yet, but we will create this object in a second. And actually first we pass in the reducer function, which we also don't have yet. And so let's create both of them outside here of this component. So initial state and the reducer, which will take in, remember, the current state and the action that was dispatched. Okay. And now let's start by creating our initial state. And here, let's create questions, which by default will just be an empty array. Now, besides this, what we also want is the loading state. So to tell the user that questions are being fetched. However, this time around, we will do it in a different way. So we will not create the isLoading state as always, but instead we will this time have a status state. And so this status will basically be a string of the current status of the application that will change throughout time. So in the beginning, our application will be in the loading state, but throughout time, we will be able to be in different states. So let me write them right here immediately. So we can be in loading state, we can be in an error state, we can be in a ready state once the data has arrived and we are ready to start the quiz. We can be in an active state once the quiz is actually running, and we can be in a finished state once the quiz is finished. Okay? And so this is a bit of a nicer way of handling all these different statuses that the application can be in. So instead of having a is loading or is error or is ready or is active states, we just have the status, and then inside the status, we then tell the application what is currently going on. So this has nothing to do with useReducer, it's just another technique. But anyway, let's now come here to our reducer function, and then let's again set up that switch statement that we already saw earlier. So this is now basically a recipe that you will always follow, so which is always the same. So at least the setup here. So we switch the action.type. So we basically want to test for different types. And let's start with the case of data received. So this will be the action that we're going to dispatch right here as soon as we actually have the data. So right here. And actually, let's do that first. So here we will now no longer log the data to the console, but instead we will dispatch an action to the reducer. And let's create our common usual event here. So that's simply with the type. And so that's the data received type, which we can also think of an event. So basically it's like here, we are now creating this data received event, which our reducer will then basically respond to. So that's the first part. And now here we also need a payload because we want to actually send some data, so send some information to the reducer so that the reducer can then use this to compute the next state. And so here, that payload will be the data that we just received. Okay. And so here, then remember, we need to return a new state object. And so we will grab all the current state, and then we will set questions to the data that we just received. So that's action.payload. But what is really great about this is that we can now set this other piece of state that is related to the question, or to questions, and that is the status. So the status and the questions many times will change at the same time. And so that's why having a reducer is so useful, because now we can here in the same place also set the status to ready. So basically we updated these two state variables, so these two pieces of state, all in one go in this one dispatch. So just by dispatching this one event right here, we updated both the questions and the status. And so we say that we transitioned to a new state by simply dispatching this simple event here. Okay, but anyway, let's also create then our default case. And so here we will, just like before, throw a new error saying that the action is unknown. So give this a save. And let's see what happens. So we are no longer logging to the console, but we should now have those questions in our state already. So we can't see it on the UI yet, but let's take a look at our DevTools. And yeah, we have our questions in the state, and the status has also successfully been changed to ready. So we transitioned to this new state where we changed these two properties of our state object. So that's working great. And now let's just create another event here, basically, for the case there is an error. So case data failed, for example. That's just one possible name. And so here let's again return the entire state, and then we simply set the status here to error. And so then later on we will use, of course, the status to display different things here in our UI in the JSX. So when there is an error, we will display that error, and if we are ready, so if the status is ready, then we will display the questions. All right. But now let's actually dispatch that action. So the type is this time data failed. And here actually let's not pass in any payload because we're not really interested in the error that we're going to receive. So all we will do is tell or state that now the status is an error. So just to test this, let's quit the process here where we load the data. So with Control-C, we can finish this. And so now we can no longer fetch data from that endpoint, of course. And so we see that we get some error already. And also here we see that the status has been set to error. So that's also working. But of course, let's go back to having our API work. And so if we load now again, then we have our questions here in the state. Okay, so we did a lot of things. So let's just quickly recap all that we did. So we installed the JSON server package to create basically this fake API, and then we created our npm script, in this case called server, to then run that package and then watch the file where we actually have this questions data as an array. So this array right here. And so then here inside our application, we use the useEffect hook to fetch that data on the initial render. Then to store that data in state, this time we used the useReducer hook. And so then we created the initial state object and the reducer. So that's pretty standard stuff. So we have the questions array and we have a status. And of course, as we keep building the application, we will add a lot more information here. So we will add like 3 or 4 more pieces of state. But for now, we are just working with these two. And so then as soon as our data is successfully fetched, we dispatch the action here where we tell our reducer that the type of the action is data received. And then as the payload, we pass in the actual data. And so then our reducer receives that action and handles it right here in this case, where we then assign the payload, so that data that we received from the API, onto the questions array. But that's not all, because at the same time, we now were able to set our status to ready here all in one go. So just with the call of one dispatch function. Now the advantage of this reducer is of course not really clear yet, because we only have these two cases yet and only these two state variables. But it will become really clear and really helpful as we go through this section. So with our reducer now in place, it's time to handle the different status that the application can have. So remember that at the beginning, our application is in the loading status. So that's how it starts. And then when we receive some data, the status changes to ready. And so that's when we will then want to display the list of questions. And also there can be an error. And so then the status changes to error. And so now we want to display different UIs for these 3 situations. And all of these situations will be always displayed inside this main component right here. So let's get rid of this. And now we will conditionally display some components. And so here we can use state.status, but that's maybe a bit too much work. And so let's actually destructure our state object. Now we could do that outside, so creating these variables here, but we can do it on the fly. So basically right here with nested destructuring. So we can have the questions and the status state destructured right here. And so now state, of course, no longer exists, but we have status. And so now we can just check, for example, if it is loading. And if it is, then we want to display something. Now in this case, we want to show a loader, and I actually also already have that loader component here. So it's again a very simple presentational component, and so there was no need to create it from scratch. So it doesn't even receive any props, and the same thing also for the error component. So exactly the same thing, doesn't receive props, has no state, and so I thought we could save some minutes and not write them manually here in the video. So here, if the status is loading, we want to display that loading component. And let's include that here. We'll just duplicate this line. And actually it's called loader. And then let's also already import the error. So here, that is loader. And then we have some problem here. State is not defined. But while I'm using state nowhere, maybe let's just try to reload. And that fixes it. Okay, and now we can just do the same thing again, because these different status are of course mutually exclusive, so we don't need any ternaries or even nested ternaries. So only this one or one of the next ones will be true. And yeah, so we can just use the AND here. All right, but here let's use the error and let's already try this out. So let's see if we briefly see the loading, and we saw, but it was very short. So just to make sure, let's do some throttling here. So make our app a little bit slower. This can be a bit smaller. Yeah, there we go. So there we are loading our questions. And now let's also pretend that we have no network connection so that we are offline. And so then when we reload, well, then of course the entire page doesn't work. So that experiment actually doesn't really work. But so to check the error state here, let's again quit our fake API. And so then we should see some error. And indeed, now here, this dispatch was called with this event type here, which then set our status to error. And so therefore, then we got this error component. But of course, let's restart our server. And so then it should be back to working. Yes. Okay. And we have another state or status that we can handle, which is the ready status. So ready basically means that the questions have arrived and that we are ready to start the quiz. So status ready, and here we will want to create yet another component. So let's just check that out. So here in the demo, and this actually is what we want to show in the very beginning. So when the app is ready. So when we load the app, you briefly saw the loading indicator there flash, and then this here is the start screen. So just with this text, number of questions, and then a button to start. So very simple stuff. So let's create a new file here for that component, and I'm going to call it the start screen.js. And then again, using that snippet RFC, which by the way stands for React Functional Component. And so here, let's place some text. So starting with welcome to the React quiz, like this. And then a paragraph with the number of questions. Let's just place an X for now. To test your React mastery. And then this div should actually have the class name of start. And here let's use an H3 instead. And then finally, also that button which says, let's start. Okay, so that's enough for now. And then let's indeed include that right here. So start, and then here VS Code this time actually suggests the import for us. So you can see that here by the path name to the file. And so if we click that, then that import is nicely automatically added. So if we save this now, then here we go. So we basically reacted, or we handled to that ready status there. Now what we want here is actually the number of questions. And so that's basically the length of the questions array right here. So the questions array has the length of 15, and so 15 is what we want to see there. So where do we calculate that value? Should we maybe place it here also into our state object? Well, that's actually not necessary. So just like we have always been doing, we can just calculate derived state right here in the app component. Because in fact, this is just derived state. Because we can simply calculate it from the question array itself. So let's just do num questions is just equal to questions. So it should be questions here. Let's see. Yeah, it's questions everywhere. So just questions.length. And of course, we could also pass the entire array into this component, but there's really no need to. And also we will need this in other places. So let's pass the number of questions equal to number of questions. So then we can receive that here. So destructuring and then num questions. And finally, num questions here as well. And beautiful. Now we get 15 questions like this. And now all we need to do is to add some more class names here, which is the btn and btn UI class. And as always, feel free to check those out in the CSS file. Okay, and so with this, we actually fulfilled our goal for this lecture. And so in the next one, we will then finally start our game or our quiz by clicking here. Now it's time to implement the functionality of starting a new quiz. So how are we going to do that? Well, after we click here on this button, we basically want to display the first question here inside this main component. So basically right here. And since we have been using this status state here to basically decide what will be rendered in the main, all we have to do now is to change that status to something else and then display that question here. And let's actually start with that. So let's say if the status was active, then here we want to display the question component. So that component doesn't exist yet, and so let's create it. So yet another component file here. Let's close that, and then our nice snippet again. So here I will just write question for now, and then of course we need to import that. Okay, well that's not correct, but yeah, now it is. So here, remember that active is one of the 5 different status that the application can have. And so now we are here basically handling that active state. So right here. So again, we are using these different status to decide what will be displayed here in this main part of the app. And it's a bit like a flow as well. So first the status is loading, then we display this. In case there was an error, then we display this. But if everything went well, then we display the next one. And then once the user clicks here, then we display the next one. So this question right here. But now the question is, how do we actually set this status to active? Or in other words, how do we now start the game? Well, all we have to do is to create basically a new action type here in our reducer, which will set the status to start, or to active actually. So let's create a new action type here, and let's call this one start. And so here we want to return a new state, as always, which is comprised of the current state and the status set to active. All right. And so now it's very easy. We just have to dispatch an action from this button here with the action type of start that we just created. So we're going to do that here. So here we will want to dispatch that action. And so therefore we now need access to that dispatch function. So it needs to be a prop. And so let's pass that here into the start screen. And so as you see, we are basically passing the dispatch function around, just like before we were passing around event handler functions or the set state functions. Right. So if we were still using useState, then we would now probably create some new event handler here, and then we would pass that event handler into the start screen. But now we don't need to do any of that anymore, because we are handling all the state transitions in the reducer. And then all we do is to pass the dispatcher functions around, because then it's very easy. All we have to do here is to then call that dispatch function with the action that we want to dispatch. So creating a new function here as always, and then dispatch. And the type of the event will be, as we just defined earlier, start. And this should actually be enough. So if we click here now, then the question component should be displayed instead of this. So let's see, and bam, there it is. So here we finished this component. And so actually we finished what we wanted to do in this lecture. So we're going to leave the actual displaying of the question for the next one. So let's now render and display the current question. So of course, we will not render all the questions at the same time here, but instead one by one. And so therefore, we need a way of knowing which the current question is. So basically, we need some way of keeping track which question is the current one. And so let's add a new piece of state to our initial state here. And we could call this the current or the current index, but I would like to just call it index. Okay, and this index starts at 0 because we will use this index here to take a certain question object out of the questions array. And so the first element of this questions array is element number 0. Therefore, our index starts at 0. And so then in the future, at some point, if we want to display the next question, we can already imagine that we will do that by changing this index. So then in the future, when we change that index from 0 to 1, that should display the next question. So it should then re-render the screen, and therefore this needs to be a state variable. All right, so that's the reasoning behind why we need this variable right here, or this piece of state, and also why it needs to be state in the first place. And again, it's because it needs to re-render the screen once it is updated. But anyway, let's now take this index to pass in the right question object into our question component. So this component will of course need access to that current question. And as we just said, that will be questions. So the array at the current position, which is index. Okay, now here that is not available because we haven't yet destructured this index out of the state, but there we go. And now let's go to this component, and just like before, if I hit the command key and then click here, it will automatically go to that component, even if it is in another file. All right, so here let's now receive that question. And then let's display it. Well, first, let's even take a look at the shape of this object so that we actually know what we are dealing with. So let's come to the console, and as we click here, that should appear. So inside the question, we have the question property. So that's what we want to use first. So here we have basically question.question. And so with this, we get the question already here in the UI. Great. But then we also have this array of the options. And so next, we will want to loop over this array and, of course, display these options as well. Now this time, I will not use an unordered list for that because we will not have list elements, but actual buttons. So here, let's call this the options. And so then here we loop over question dot options and then dot map. So here each of them is a question, or actually it is an option. And so then for each of them, what I want to do is to return a button with the class name of btn and btn option. Okay, and then as for the text, it should simply be the option itself, because as we see, this is just a simple string. So each of the options is just the string, and so that's already looking great. Let's just see what we have here. Of course, we are missing the key property. So very important for optimization, as we have already learned at this point. So the options are unique, and therefore we can use each of them as a key. So as we reload, then let's start. And there is our first question together with the options. Nice. Now here, actually, I would like to split this component in two. So whenever there is a list like this, I personally prefer to have a smaller component in a situation like this. So based on the logical separation of the content of this component, I would say that we can now split this component. So let's grab this entire part and let's create a new component. And actually we are creating so many components that it is a common practice to create a new folder called components. And so this is where we then create the components. So let's do this one right here, and then I will later put all the other ones there as well. So options.js, and then our snippet again. And here we already have the JSX. So let's place that there. Now here this is missing the question, but let's first of all place all the other components into this components folder. So that's app, the date counter, error, header, loader, main, question, and start screen. So we already have a lot of components here. And so let's place them all in there. Now, of course, we will have a problem in the index.js file because it is still trying to read the app component from the same folder as before. But so now it's in the components folder, so we need to change that here. But then all the other will still work because we are importing them here inside app.js. And so here we are importing them from the same folder, and so that's why this still works. All right, but anyway, coming back here to our options, here we now need to receive the question. And so then, of course, we need to pass it in there. So we need to even import that here. So options, and then with the current question. And then just importing that here. So import options from, and again, it's the same folder. And let's test. And there we go. Now, of course, when we click here now, nothing happens. And so that's what we will take care of in the next video. Now, in this lecture, we are going to implement the logic for handling a new answer. And to understand what that means, let's check out our demo project here, and then let's give a new answer. So a new answer is basically when we click on one of these options here. So let's do that, and you see that basically three things happened. So first, the correct and the wrong answers are displayed. Second, the points that we got were updated. And third, the next button was displayed down here. So basically, when we click on one of these options, we need to re-render the screen. And so, once again, that means that we need a new piece of state. And so that state should basically store which of the options was selected. So in other words, which was the answer? So answer 0, 1, 2, or 3. So basically the answer is just going to be the index number of this option here. So let's come back to our app.js and add yet another piece of state to our initial state. So let's just call that answer, and in the beginning it will be null. So there will be no answer initially. And so that makes sense, right? And now next, let's then create an action in our reducer to update that answer. So let's do that, well, after this one here. So let's keep them in order. And here, let's call this one new answer. So then later we will dispatch a new action with the new answer type, right? And so here, let's return, as always, the state, and then the answer will get set to the action dot payload. So very simple stuff. And so now we need to go here into our question, or actually into these options, because here is where the click on the button will happen. So here is where we will now need to dispatch a new action. So that means that we need to pass the dispatch function into questions, or into question actually. So this patch, and then the dispatch function, and we will also need the answer that we gave. So this one we need so that we can then display if the answer that was given was correct or not. So painting it basically with one of these colors. And again, we need to destructure this first here. So we need our answer. Yeah, so dispatch and answer. So let's grab them here. And then passing them in here. So a bit of prop drilling you can maybe identify here, but that's not a big deal if it's like just this one level. So then accepting these two props here, and there we go. Now we can from here dispatch the action. So on click, so dispatch, and the type of this event, well, let's see, I don't remember. So that's new answer. And the payload should then be the answer that was given. So new answer, and the payload again is the answer. Now, what is the answer? Well, remember how we said earlier that the answer is basically the index of the option. So in this case, that would be here index number 1, right? And the reason for that is that the correct option is also marked using these same indexes. So I just want to show you that, because I think that besides learning the React part, it's also important that you learn how to build applications, basically. Now here our app changed to a different state, so the finished state, but never mind. So what I was saying is that the correct option here is also using these indexes. And so indeed, here the correct option is React, and so that's index number 1. All right. So then how do we get the current index here? Well, we can just get it here as the second argument of the map method. So that's just how this method works, where the first option is the current element of the array, and the second argument is the current index. And so this is all we need. So let's check that. Let's click maybe here this time. And so then when we come to our state, we should have the answer of 2. And well, where is that? It's not really anywhere. So let's reload. Maybe I forgot to reload the application. Let's try that again. And apparently I did. So now we got the answer right here. Nice. And so next up, let's then do some formatting based on this answer. And so that's why these options here received that answer prop. So that stayed right here. So what we're going to do is to basically change the class names here conditionally. So let's create a template literal. And then first of all, let's create a class for the selected option. So here, let's say if the current index is equal to the answer, then add the answer class. And otherwise, don't add anything. So when we're doing conditional CSS, we should always use the ternary operator so that in the opposite case, so in this third branch here, then we return no string at all. And so you saw that here, the question that we selected actually got this special class where it moved a bit to the right. And if we selected this one, well, then that one would get that special class. So that's the first thing. And now we also then basically need to paint them in the right color, depending if the option is the correct option or not. So let's again enter here the JavaScript mode. And then let's say if the current index is equal to question.correct option, then add the class correct and otherwise wrong. And beautiful. So that's working. And again, let's just check our state here so we see what's going on. So again, each of these options or of these questions actually has the correct option as a property here. So that's number one here. And so number one in this case here, so in this option is equal to the index. And so therefore it was then marked as correct and all the other ones as wrong. Okay, and now we can actually click multiple times here, but of course that should not be allowed. So once the user clicks on one of these options, then it should be logged in. And so we then can no longer click. And so let's just disable the button with the disabled prop. And in here, basically we want to know if there was an answer. So any answer at all would then disable this button. So since we know that the initial state of the answer is null, we can just check if the answer is not null. So if it's not null, means that there was an answer, and then we want to disable the buttons. So let's try that again. But we have some problem here. So all our options are already painted. So that's very bad because it gives away the correct option here. And so actually what we did here was not really correct. So basically classifying each of them as correct and wrong. We only want that to happen if there was an answer at all. So basically in this situation. So we need to reuse that. So let's just place that in a special variable. Let's say has answered. Okay, and then let's use that here. And here as well. Now here this will become a bit confusing. So we use a ternary and then another one. So we have nested ternaries, which is pretty ugly. So we could actually do this outside as well, but let's just keep it like this. So it is readable if you understand the logic behind this. And so it looks as though now it is correct. So let's select something here. And yeah, now we cannot click on the other ones. And also everything is marked in the correct way. So we selected this one. So this one got the special class, but it is wrong. So it's then yellow and only this one is blue because it is correct. So it has the correct class then. Great. So we took care of one of the three things that should happen. So again, the correct answers should be displayed. Then the user's score should be updated, and the next button down here should be displayed. So let's now quickly take care of the second part. So basically that the user's score should be updated. So that is something that needs to again update on the screen, which means that we need yet another state variable. So let's call this points, and the user starts at 0. Okay, and now where do we update these points? Well, it makes sense that it is exactly in the same place where we received the new answer. So right here, we will also update the points. So how are we going to do that? Because of course, the points should only be awarded if the answer was correct. So we need to first figure out which is the current question, then if the answer is correct, and only then we want to add the points to the current points. So that sounds confusing, so let's just do it. So first of all, let's figure out which is the current question, because we actually don't have that stored in the state. So we only know the index, but not the question itself. So let's grab state.questions at state.index. And so here, really, we are leveraging the current state that we get into the reducer to compute the next state. So really relying on that current state. So with this, we know which is the current question. And so now we can then check if the current question is equal to the received answer. So that received answer is again action.payload. And now let's check if it is equal to question.correct option again. So this property that we have used before already here. Right? So if that is the case, then we want to add some points to the current points. And so that is state.points plus something. Let's just do 1 for now. And otherwise the points will just stay the same. So then we will just return again state.points. Okay. Now here we are adding 1 for now, but that is not what we want to add in the end. Because notice again how each of our questions object actually, let's give a lot more space. So each of them has this points property, which is because each of them actually has a different points value. So the easier ones only give 10 points, but then if they are more difficult, well, let's maybe this one. Well, not really. So there are some hard ones, yeah, like this one. So this one adds 30 points. And so we need to get actually that value. So that is at the current question dot points. All right. So I understand that this here might seem a bit confusing, but this is really just understanding what kind of data we have and then working with that data. And also you notice that here we now have, for the first time, quite a more complex state updating logic in our reducer. And this is perfectly fine and actually encouraged. So whenever it's possible, we should try to put as much of the logic for calculating the next state right into the reducer. So it's better for this logic here to be in the reducer than in the place where the event is actually first handled. So basically we could probably also do this calculation right here in the option where we handle the event, but that would go against the logic of the useReducer hook. So it's much better to do it like this. All right, so this should be working. Let's check it. So we know that this question is worth 10 points. And so if we select the correct one, then you notice that our points have indeed been updated to 10. So that's 0 plus 10. And if we select the wrong one, then our points stay at 0. Great. So of course we will later then display these points in the UI, but let's leave that for a bit later, because next up we need to take care of displaying the next button and handling the logic of actually moving to that next question. So basically, when we finish here, then we want to click and go to the next one. And so that is what we will do in the next video. So now we have the simple task of moving to the next question as soon as an answer has been given. So as soon as the user clicks on one of these options, we want a button down here to appear that we can click. And so then we will move automatically to the next question. Now, as we have discussed before, moving to the next question basically means increasing this index here, right? Because it is based on this index that the current question is being read and then displayed. So that's what we do right here. So we're passing in the questions object that corresponds to the current index. And so let's now here create yet another possible action in our reducer. Now let's call this one just next question. So here we will just return the current state, and all we want to change is the index property, which will be set to state.index plus 1. And that should be it, at least for now. And so now we need to create actually that button. So besides the question, we want to then display the button. And so let's actually always display a button component, but that button component will then only render the button element itself if there has been an answer. So we could also do it the other way around and do the conditional rendering right here, but instead we're going to do that conditional rendering inside the button. So we will allow this next button to basically decide if it wants to render itself or not. And so since we want to dispatch an action from there, we need to pass that in. And so now, of course, we need to create this component. But before we do that, here we have a problem because we need a fragment now. Okay. And now, as I was saying, we need to create this new component right here. Okay. And then let's already receive the dispatch function, but we also need the answer. And so that's because of what I was saying earlier, so that we want this component here to allow if it wants to render the button or not in case there has been an answer. So let's pass in also the current answer. And of course, we then need to import also this component here. So just duplicate that. And yeah, I think that should be it. So let's go back here and accept that answer prop. And so now we can say, so doing an early return, we can say if the answer is null, which remember means that there has been no answer, then just return nothing here. So just return null. And otherwise, then we actually create a button. So here we say next, and the class name should be btn and btn UI. And then finally, the onClick handler will be a new function. And then, of course, we dispatch a new action. And so remember, this one is the one we just created, which is next question. And for this state transition that this will trigger, our reducer doesn't need any data, and therefore there is no payload here necessary. Okay, and let's see if this works. So let's start and let's click. And indeed, there is our button. And so let's now test. And yeah, it moved forward to the next question, but we still have a problem, which is that our answer has not been reset. And so therefore, we are still showing the previously given reply. So that's easy to fix, but what matters is that we can now actually move through these different questions. So let's then just quickly fix that problem. And so all we need to do is to again come to our central place where all this state updating takes place. So what should we do here? Well, we just need to set the answer back to null. And that will fix it. And once again, we can really see here in action how all these different state variables closely belong together. And so the useReducer hook really was the perfect solution for managing our state in this application. But anyway, let's now again test this. And yeah, that fixes it. So let's try another one here. And this one is components, just to see if our points are correctly updating. Yeah, and they are. So now we have 30 points, which is 10 points for each question that we just successfully answered. And speaking of these points, we now actually want to display them up here. So the current points out of all the possible points together with the progress that we have been doing. So basically displaying this part right here. So don't wait and let's move together right to the next video to do that. So let's continue building our application and display the progress that the user has been making in the quiz. So basically what we want to show is this right here. So the current question out of the number of questions and the current points out of the number of points. And then also this nice progress bar. So basically what we want to do is to, besides the question and the next button, also display a progress component. And let's actually first go build that component. So new file, just calling it progress, and then scaffold our new component like this, and then let's get to work. Now here let's actually use a more semantic header element, so a header inside the main part. So that's perfectly semantic, and so I think it's a good element to use here. And let's give it the class name of progress. Okay, and let's start with one paragraph for each of these sites right there. So here we need the current question. So remember, that is the index. And then let's place it inside the strong tag. So just write it again, that's easier than to copy and paste that. And then here we also need the number of questions. So these things we will need to receive as props. And this of course is called index, not just I. So index and num questions, I believe it is called. And so let's already try this out. So progress, and I'm selecting this one here from the list, again, because here this shows me that this will then automatically import the component into this page, so into this file. So we need, again, the index, and we need the number of questions. Okay, so let's see. And yeah, we already have something. Let's just start from scratch. And so now we see that we have question 0 here. And so that's, of course, because the index is 0 based, but our users don't know that. So it looks a lot nicer if we just start at 1, right? Then next up, we want the current points. And again, let's make them bold. So that's points, and then out of all the possible points. So that will basically be the sum of all the points of all the questions. However, we don't have that value yet. And so, well, let's go compute it. Let's just write an x here. Take the points so that we can correctly display our component. So points. And apparently we haven't destructured that yet, but it should be in our state, because I remember how we updated it earlier. And yeah, now it is 0. Okay, and now let's get the maximum amount of points that the user can make. And so that again is derived state, because we can just compute that from the questions array. So let's say max possible points. So that's questions.reduce, because we want to reduce this into just one single value. And so here the callback always gets the previous value and the current value in the array. So that's the first argument. And then the second argument is the initial value. And so now all we need to do is to add the previous value, so the one that starts at 0, with the current question dot points. So just a normal regular reducer right here. So that should be nothing strange for you at this point. And so let's then pass that in and copy that and then replace our x right here. So let's see, and beautiful. The only thing that we are missing is, well, here we now need to restart because this one times out after a few minutes. So we also want this progress bar here that keeps going as soon as we complete more questions. So you see that it keeps going. And this element is actually a progress bar. So this one is a new one, or at least one that I haven't really used before. And so here we can define the max value that this can take. And here it makes sense that this is the number of questions. So it will go basically from 0 to 15 in this case. And then we can also define the current value. So this is basically like an input element. And so here we are making it a controlled element in a way, even though we cannot really set the state on the progress bar. But anyway, here the current value will be the current index. And here it's actually the index, not index plus 1, because we actually want this to start empty. So when we come here, we want it to be empty at the beginning. And so let's see. Let's click here. And now you see that it didn't really move. It will only move once we click here. So then it moved here to 1. So if we inspect this element, we will see that the max is 15, of course, and the value is 1. So we can change that here just to see. For example, this is what it would look like with 10. And then with 15, it would be completely full. But anyway, the behavior here is slightly different, because here when we click, then it immediately moves to the next one. So right after we click. So somehow, basically this detects if there is an answer. And if so, it then immediately moves this value forward. So let's implement that here. So we can just pass in the answer. And then I will show you a very nice trick that we can use. So we can convert to a number the Boolean that will result from checking again if there is an answer or not. So doing this. So basically what this does is that if there is no answer, then this is false. And so then number will convert that false to a 0. But if there is an answer, then this will of course be true. And then that true will be converted to 1. And so then we add 1 to the index. So let's see. And, well, that's already at 1 here. But that's because I didn't pass in the answer. So right now the answer is then undefined, and undefined is different from null. And so that then gives already 1. So of course we also need to pass the answer as a prop, but this will then fix it. So as you see, it's just completely normal that these unexpected small mistakes happen. But in any case, now that's fixed. And so this is what we were looking for. So it keeps going forward all the way until the end, which I will not do now, as that takes just a bit too much time. But anyway, with this, we successfully finished the task that we had for this lecture. So let's close this one. We don't need anymore, nor this one or this one. And so with this, let's now move forward. Our next task is to implement the functionality of actually finishing the quiz. So after the user has given an answer to the last question, we no longer want to display all of this here inside the main component, but instead we will want our application to move into a finished status, so that then we can display like a finish screen here. So in the beginning we have a start screen. So when the application is ready, then while it is active, we show the progress, question, and next button. And then when the user is actually finished, we will have the status set to finished. And so let's handle that state here, that status state. Even though we don't have any button yet or so, that will trigger the status to become finished. But let's implement this anyway. So we want, or actually let's create the component first. So finish screen.js. And then here let's return a paragraph that says you scored, and then the score. And let's actually wrap this into a strong tag. And then out of all the maximum amount of points. So that's max possible points. And then let's also calculate a percentage. So let's do that outside here. So as a derived state, basically. So let's say that's the points divided by the max possible points times 100. So let's take that and use it here. So let's round that down then. Percentage. Now, okay, but of course our code is complaining that none of this exists, because of course we will have to receive this as props. Okay, so now our component is happy, but of course it's not yet being displayed because we need to include it here. So finish screen, just make sure that it got automatically imported. I'm not sure it did. Yeah, actually it didn't. So let's try that again. Yeah, just like this. So we pass in the points and the max possible points as well. Okay, but as I mentioned earlier, nowhere in our code we can make the status change to finished. But just to test this, let's do that here. And so that's one of the great advantages of having these DevTools. So right here, we can change any value that we want, for example, to finished. And so then we see that we got the component that we just created. Here we're just missing the class name. of result. So that looks a lot better with the percentage sign as well. And then later we will also include like an emoji here. But let's leave that for a little bit later, because for now we actually want to trigger the status to become finished. So when should that happen? So let's just restart here. And now let's go to one of the last questions. And again, I will simply change the index now here, let's say to 13. And so with this, we are almost on the last question. So let's just reply anything here. Next again. And so now we are on the last question, right? So with the index of 14. So when we select anything here now, what's going to happen once we click here? The index will just go to 16 or to 15 actually, and then we will have no question to display. And so it is in this situation where we actually want this button here to not go to the next index, but instead to change the status here to finished. Okay, and so that's what we will implement next. So as I click here now again, then we get an error because there is no question with that index. All right, and so let's go here to our next button and say that actually we only want to return this kind of button that dispatches the next question event if a certain condition is met. And so that condition is that the index is less than the number of questions. So for that, we will then, of course, have to pass that in here. And here it's actually -1 because the index is 0 based, but the number is not. Okay, so let's pass in the index and the num questions. So there we receive them, and here is where we pass them in. So num questions equals num questions, and then the index. So you see there is a lot of props being passed around in this application, but we will actually learn a nice solution to this problem. So it's not really a problem, but we can make it a bit nicer with some tools that we will learn about later. But anyway, let's just simulate this again. And so if we now go to the index of 14, then as we finish, we should no longer see that button there. And that's right. So this time we cannot move forward. And so with that, we prevented that bug that we saw earlier. But now we then, of course, need another button. So let's say then if the index is equal to the number of questions -1. So that's our 14 in this case. So in this case, we say finish, and then here we will want to dispatch something else. So let's say an event called finish. So let's then add, or basically handle that right here in our reducer. So finish, and this one is going to be quite simple. Again, at least for now, because here all we do for now is to set the status to finished. So let's reload here again. So I really don't feel like going through the whole quiz manually. And so let's just type 14, click on anything, and yeah, here we got our finish button. And so now as we click here, yeah, beautiful. So our status changed to finish, and we got, of course, the finish screen right here. Okay, let's just make the screen a little bit nicer with some emoji here, which will express basically how well the user did. So let's create a let variable here. So I think I'm doing that for the first time in this course, but that's just because we will now have a lot of conditions here. And so this is the easiest way of doing that. So basically, according to different values of the percentage, we will now assign a different value to the emoji. So giving it a different emoji. So here let's go for a medal, like this. Then we can say else if, or actually since these will be mutually exclusive, we don't even have to do that. So just a normal if is good enough. So greater equal 80. And here, if you don't want to spend the time doing this, you can just fast forward a little bit, but less than 100. Then our emoji, let's see. Let's use the party emoji this time. And let's just do a couple few more. So if it's more than 50 and less than 80, and then if it's greater than 0 but less than 50, and finally let's do one if the user fails all of the questions. So let's use a face palm for this one. Then here, let's just use like a thinking emoji. Well, not there. And then here, let's just use, well, not to use a happy face. For example, just this one here. And so then let's just include that right here. So that looks a little bit better, gives the user like an immediate feedback. Great. So this works really great right now. There's just one more feature that I actually want to implement, which is a high score. So if the user does the quiz and then they score 100 points, but then the next time they do it again, then they score 200, then we want to store that 200 as the high score. And so if they then do it for a third time, but then they score, let's say 150, then the 200 stays as the high score. And so we want to also display that here as a paragraph. So use the class name of high score. And then let's just write here between parentheses that the high score is, for now, X points. And then here, let's actually return a fragment because we don't want to pollute our markup here with some unnecessary diffs. Okay, so when and where and how is the best way of calculating this high score? Well, I think that the best place to do so is exactly when the user finishes the game. And so that is right here in this finish event. Right, so when this happens, the game finishes. And so here we can perfectly fine calculate the high score. So this is another piece of state because of course we need it to be remembered across re-renders. So here we also start at 0. And yeah, then let's update the high score as the game finishes. So we can just do state.points, which are the current points at the end of the game. And then we can compare that to the current high score. And so if it is greater than the current high score, then here we want to assign that new value to the high score. So then that's going to become state.points. But otherwise, here actually is the question mark. But otherwise, then the high score will simply stay at state.highscore. So let's manually reload so that our state gets that new high score. And I will now manually set it to, let's say 20. And then let's start our game. Let's just do a few of them here, just so we get more points. So now we already have 30 points. And so let's then move on to the last one. So we skipped all of them. So hopefully our users don't do this. But yeah, let's now just click anyone. Oh, that wasn't even on purpose. But anyway, we have 30 points. The high score is 20. And so let's see what happens. And you saw that the high score got indeed updated to 50, because of course those 50 were more than the current high score. Okay, so let's get that out here. So destructuring out of the state so that we can then pass it into the finished screen. So high score will be equal to high score, and then let's write that here as well. So high score and then accepting it here. High score. But now I'm not going to test that again because we can be pretty sure that it works. Now here we now have one final thing, which is this button to restart the quiz. So right now we are still missing that. So again, I'm not going to show that. But so basically in the end, we will want to have one button to start the quiz over. And so that is what we will implement in the next video, where we are then almost done with the application. So after a quick break, let's now finally build the simple feature that allows a user to restart a quiz. And with our reducer that we already have in place, this is almost too easy now. So we have updated related pieces of state so many times in this section so far that I think that you could actually implement this on your own. So this entire feature, you might be able to just build it on your own now. So I think that might be a really nice challenge. So just add a button here with the same classes as I think this one here, or at least the same classes as this one. So basically it's just the same thing here. And then you just create a new action and then basically reset the state there. So that should not be too hard. And so please do that now and meet me back here once you are finished. So I hope that was fun. So I will just now copy and paste this button here. So place it right underneath this one right here. And then of course we need access to the dispatch function. Here the text will be restart quiz. And then here let's dispatch an action with the type of restart. So very creative. All right. And going back to our reducer, case restart. And so here we could now do this in two different ways. So we could define all the variables that we want to reset to their initial state. So just like this, for example, setting the score back to 0 and basically doing all of this here, because actually we want to restore all of them except for the questions array. So this one we don't want to refetch, of course. And well, probably we also want to reset this one here to ready. But these other ones, they should become exactly the values that we have right here. So let's try to do this. So we expand the entire initial state back here, and then we just add the questions back in. So we say questions is equal state.questions so that we don't lose them. And then finally, the status should become ready. But again, you could just as well have done this. So return the entire state, but then overwrite like the points back to 0, the high score back to 0, the index back to 0 as well. And there was just one more, which was it? The answer back to null. Answer back to null. And of course, the status to ready. So both of these work. I just prefer this one here because it's a bit more explicit that we basically want to reset to something similar to the initial state. So this was really easy, wasn't it? And so I actually really like this pattern. So it makes the state logic that we have here, all of it, so decoupled from all the different components. And this is especially helpful when we later come back to the code and want to understand what is happening. So then all we will have to do is to basically read through these cases, and by that we can then understand what happens in our application and how the state transitions. So even without understanding much of the application, just by reading the reducer, we will know that some data might be received, that it might fail, that something will start, that there can be a new answer, that there can be a next question, and so on. So again, just from reading the reducer. And so because of this, our state updates are really a lot more declarative. So we just map these different actions here to the state transitions that we then write out right here. So really, really amazing pattern. But I will talk more about that again by the end of the course when we summarize everything that we learned here. So now let's actually just test this. So let's start, and then I will cheat again, and going back, or actually going forward automatically to index number 14. Then let's click here. Oh, actually this is the demo version. So that is then really cheating, right? Because that's already working. So yeah, again, 14. And so we have just 20 points. So I guess we won't beat the high score. Or actually we will, because of course it's also reset to 0. And so here we then have the same as before, but now we can restart the quiz. So let's see. And this patch is not a function. Nice. So we didn't pass it in, I guess. So of course we need that here. So let's do it all again. And if you want, you can of course go through the entire quiz, which I really hope you do. That's why I added 15 questions to it, so that you can practice a little bit. But anyway, let's now click here, and nice. So the questions remain the same, but everything else is reset. Great. So that was actually it. So we finished that part as well. All we have to do now is to get this timer here to run. So when this timer runs out, then basically the quiz stops. So you see here that it keeps updating. So let's set it like to 5 seconds. So we see what happens here at the end. So let's wait for it. And so then you see that it automatically moves to the finish screen. And so let's now implement this functionality in our own application. Welcome to the last lecture of this project. And in this one, we're going to use our old friend useEffect to implement a timer feature. And this new feature will play really nicely with the reducer that we already have. So when the game is going to start, the timer will also start, and once the timer reaches 0, we will have the game stop by setting the status to finished again. So we will be able to model this behavior really beautifully with our reducer. So let's start by creating a timer component which will display the current time that is remaining, and that will actually also start the timer in the beginning. So that component should be right here at the bottom. So I mean at the bottom here of our UI. So basically down here besides this button. So what we want is actually for these two components to be inside a footer. So we will want a timer. So the component that we will build next. And then we want, again, these two inside a footer HTML element. Now this is ugly like this. So as you already know, I really don't like to see it this way. And so let's just quickly create ourselves a footer component. Okay, and so all this will do is to return a footer element, which will then contain the children that we pass in. All right, so doing some more component composition here. And of course, we could also just call both the timer and the next button in here, but then we would have to pass all the props in here just to then pass them into these other components. And so that's not really necessary. So footer, and let's also create the timer immediately here. And then let's just return the timer string for now so that we can then import these two components into our application here. So the timer and the footer. So that's all the components we are going to build. And as you see, there are a lot of them. So I like to keep them a bit separated from the other imports. But anyway, let's now see what we get. And so here we have our timer, basically. So it's not really a timer yet, but so let's now change that. So first of all, it needs the class of timer, and then let's pretend that here we have just some time. So just so we can see something. So this already looks a bit nicer. Okay, and so here, let's now again use the useEffect hook to create a side effect on mount. So as this component here mounts, we basically want to initialize the timer. And we are doing that right here. So we are starting the timer here in this component because this timer component will mount as soon as the game starts. So of course we couldn't start the timer in the app component here because then the timer would start running as soon as the entire application mounts. But that's not what we want. So we have to place this effect into one of the components that mounts as the game starts. I mean, there would of course be ways around that, but I think it makes just sense also that this effect is here in this timer component. But anyway, how do we actually create a timer in JavaScript? Well, first of all, this of course needs to be a function here, but then we will now use the setInterval function. And so this function will simply run the function that we pass in here every couple of milliseconds, which we can also define. So let's pass in our function, which could also be an arrow function here, by the way, but let's just do it like this. So for now, we want to log to the console the string of tick once per second. And so that's every 1000 milliseconds. And this will already have started the timer now. So if we come here to the console, then you see that every second, well, now we actually get 2 ticks here, but that's again because the effects run twice in development mode. So this wouldn't be happening in production, but now it does. Okay, but of course, what we want to do here is not to log something to the console, but instead we want now some value. So we will want some state value that we can then decrease every second. So let's take out this console.log here for now and reload our page so that we don't create any additional work for the page. And then let's come here again to our state and add one final piece of state. And so that is going to be the seconds remaining. And we could do it also the other way around. So we could start at 0 and then add 1 every second until we reach a certain number. But here instead, we will start at some number. So for now, let's just say 10 seconds. And then we will remove 1 second every second. And once that reaches 0, so once there are no more seconds remaining, then we will finish the game. So let's now implement what I explained. And so once again, we will just leverage our reducer here again and add one final event here. And this one, I'm going to call it tick. So because, like a clock, this will happen every second. So this is the event that we are going to dispatch here in this function. And why not actually do it immediately here? Since we are already here, let's dispatch the event with the type of tick. Then we need to give this access to the dispatch function. And here it is not dispatch event. And now VS Code is complaining, or actually ESLint, because dispatch is now a dependency. So let's add it then if React needs it. And so now, of course, don't forget to pass it in. Not like we did in the previous lecture. And now we are ready to model here our state transition again. So we want all the state, and then we want seconds remaining to be equals state.seconds remaining minus 1. So as I said a minute ago, we will simply subtract 1 second every second. Okay, and now let's also pass that into the timer so that it can display this value. So seconds remaining here, taking it out of the state, and then seconds remaining here. And then of course, we also need to accept that as a prop here. And yeah, then place that right here. And with this, we should be good to go. So let's see. And yeah, that's working. Great. Now, of course, for now, we are still allowing this to go below 0. And so let's fix that next. So basically, we now want to check every second if this has reached 0. And if it has, then we will finish our game. So exactly like we have been saying in the very beginning. So this feature fits now really, really nicely into the entire state structure that we already have. So we can just now use again the status. And then we can check if state.seconds remaining is equal 0. And if it is, then here we return finished, and otherwise it just stays the same. So that's then state.status again. So this right here is the entire heart of this feature. So basically allowing us to check if the seconds came to 0. And so if they did reach 0, then we just set our status to finished, which will then trigger the entire game to stop. And to then, of course, render this finished screen instead of what we have here in the active state. So let's reload and let's see. So that's why we used a small number, so that we can see immediately if this works. And it does. Great. And even if we restart the quiz, then it starts again at the value that we had before. So that is because here when we restart, we just took the entire initial state here again. Remember that? But maybe you noticed something here when we restarted the quiz. So let's try that again and see how fast this goes now. And if we do again, it will be even faster. Actually, we don't even have to start the quiz that this moves now to the finish screen. So clearly something is going wrong. So notice how fast this goes. And the reason for that is that our timer actually does never stop right now. So we have no cleanup function, and so therefore our timer here will keep running even after this component has unmounted. So that of course we need to fix, and so this is an amazing use case for the cleanup function. So what we need to do is to store the ID of the timer that gets returned from this method. And so we can then use it in the cleanup function that we return from here. So to clear an interval, we basically just have to pass in the ID of the timer that we started with set interval. So every single set interval timer will return a unique ID. And so we can then again use that to clear, so to cancel that timer. And so now this will run between renders and even more importantly, after this component is unmounted. And so then the timer will really actually stop. So what we had before was that each time we restarted our quiz, a new timer got added. And so then we had many timers running at the same time, which were all dispatching this action. And so then our time was going down really, really fast because of that. But this should fix it. So let's try that. And actually now we are only going down 1 second at a time. And there we go. So that was expected, but now let's see again if the timer has the same speed as before. And yeah, it does. And so it means that this cleanup function here is indeed working. Now notice how here we are getting all of these renders, or actually all of these console.logs. And that's because, of course, now the entire application, so all the components will re-render every single second. So let's just quickly review what we learned before. And that is that as one component re-renders, all its child components will re-render as well. So our state lives here in this global app component. And so therefore, as our state re-renders, so will re-render all of these child components. And so that is, of course, also true here for the question component that does this render here, which will then create this log here every single second. So let's just quickly clean that up right here. Okay, and so this could become a performance issue in a really large application with like 1,000 components. So in that case, you probably shouldn't have your most parent component re-rendering every single second. But in this case, this is really not a problem. Now, of course, our 10 seconds that we have here are not nearly enough, right? And so what we want to do now is to calculate the amount of seconds from the number of questions that we have. So let's do that. So our seconds remaining start at 10. But again, we want to now calculate it from the number of questions. However, we don't know that number at the very beginning, right? And so let's just set this to null and instead calculate this number here as we start the game. So at this point, when this action is dispatched, we will already have the questions array. And so then here we can calculate those seconds remaining. So let's say state.questions.length, so the amount of questions, and then maybe 30 seconds per question. Now, we shouldn't actually place like a magic number like this here. So instead, we should always create a constant out there for a value like this. Otherwise, it will be really weird and unclear to suddenly see a 30 in here. So let's create a constant that will be called seconds per question. And it's kind of a convention to have these as uppercase. So secs per question equals 30. Okay, so that should work now. And yeah, now we have plenty of time, I think, to complete the quiz, which again, I hope you will do, or maybe you already have done here outside of one of these videos. But now to finish, let's then also format this a little bit nicer. So for example, separating the minutes from the seconds. So let's create a minutes variable here. So let's do math.floor. And so then we just divide the seconds by 60. And so this here will give us the amount of minutes. And then we round that down with math.floor so that we can then, besides the minutes, also display the seconds. And so this will be seconds remaining, and then the reminder of dividing that by 60. So that's, again, just pretty standard stuff. And then here, let's display that. So minutes and seconds. Give it a save. And now this doesn't look really nice, because ideally we also want like a trailing 0 there in some situations. So not now, but if it is less than 10. But that's pretty easy as well. So minutes less than 10. And if so, then just place a 0 there. And so there it is. And well, then the same thing for the seconds. So seconds, and right now that's not the case, but we will maybe see it in a second or in 20 seconds actually. But yeah, we probably don't have to wait for that, because actually with this we finished our application. So it's feature complete now. The only thing that we might do is to fix our title. So let's come here and call this the React quiz. And there it is. Beautiful. And now we really are finished with this application. So congratulations, you just added one more really nice React application to your portfolio. So I hope this was a fun one. I sure really liked to develop this one with you. So we learned a lot about reducers and to use reducer hook, but also, again, we learned some more about React development in general. And you could take this project even further if you wanted. So I have at least 3 ideas for features that could be implemented. So first of all, in the start screen right here, we could do different kinds of stuff. For example, allowing the user to only select a certain number of questions, or also to allow the user to filter for the difficulty of questions. Now, another thing that we could do is to upload the high score of the quiz to our fake API as well. And then, as we reload the application later, that could then refetch the high score and place it back in our state so that we don't lose that value. And finally, another idea that I had is that we could store all the answers here in some array instead of just the current answer like we do right now. And so by doing that, the user could then go back and forth in time and review their answers like that. So if you want, you can have some more fun with this project. And if you do, please make sure to share some GitHub link or something like that, or maybe just the final application in the Q&A of this lecture. And so now, to finish this section, we will quickly review what we learned about useReducer and compare it with the useState hook. So see you there soon. To finish this section, let's review what we learned about useReducer by comparing it with useState, both in terms of how they work and when we should use each of them. So, as we already know, useState is ideal for single pieces of state that are independent from each other. So things like numbers, strings, and also arrays or simple objects. On the other hand, we reach for useReducer when we have multiple pieces of state that are related and dependent on each other, or when we have some really complex state on our hand. Now, when we have a few states with useState, the logic to update that state is usually placed right into event handlers or effects, and these might be spread all over the component or even located in child components if we're using lifted state. And that's where one of the big advantages of useReduce comes into play, because with useReduce, we centralize all state updating logic in one place, which is the reducer function. And with this, all that logic is nicely decoupled from the components. Then, whenever we need to update the state, we just dispatch an action to the reducer, which knows exactly how to perform state updates for different actions. So, essentially, reducers map state transitions to actions with well-defined names, which makes them a lot more declarative. And going back to the game example from the first lecture, instead of setting 3 separate states like these in order to start a game, we can just dispatch the action start game, and the reducer will then take care of the rest. And this really is an amazing pattern. The only downside of this approach is that it can be a bit more difficult to understand and to implement. It can take a bit more time, but that might be worth it. Now, just finishing our comparison here, with useState, of course, we do not dispatch any actions. All we do is directly updating state by calling the setState function, which leaves us with state updates that feel a lot more imperative when compared to dispatching an action. But on the bright side, this of course is a lot easier to understand and to use, because we don't have to write any reducer function. And most of the time, this is completely fine. And so then useState is the way to go. And this actually brings us to our next and final slide, where I'm now going to give you a simple framework for deciding between useState and useReducer whenever you need to add state to a component. So the first and most obvious question to ask ourselves is whether we only need one piece of state. If that's the case, then the answer is very simple. We just use one useState hook and call it a day. Now, if we do need more than just one piece of state, the next question to ask is, do my states frequently need to be updated together? So just like in that game example from earlier. And if the answer is yes, then we might have a good use case for a useReducer. However, there's probably one more question that we need to ask first. Are we willing to actually write a slightly more complex useReducer hook with a reducer function? And if we are not, then we just keep using the useState hook. But if we are okay with taking the time to write a reducer, then this is definitely a good use case for useReducer. Nice, so let's keep going. If our state does not update frequently together, then the next step is to figure out whether we need more than 3 or 4 pieces of related state, and whether that state even includes some objects. So this is what we can call complex state. So in this case, and if we're willing to actually write a reducer, then useReducer is again the way to go. Finally, our state might actually not be that complex, but we still feel like we have way too many event handlers that make the component and also its child components too large and too confusing. In that case, you might also consider going with useReducer. Otherwise, if the question is no again, then useState is once again the way to go. So, in general, even after learning about useReducer, useState should probably still remain your default choice for managing React state. But if useState gives you one of these problems that we have been talking about, then it's time to consider a useReducer. And that's actually it. So at this point, you are probably in the top 5% of React developers when it comes to understanding the use reducer hook. So you're making excellent progress, really. And now, to finish, it's time to practice the use reducer hook on your own. Let's continue our tradition of finishing a section with a challenge. And in this one, I want you to build a very simplified bank account like this one. So this is similar to the analogy that I gave you when we first talked about the use reducer hook. The difference is that here we don't have any account numbers to just keep it really, really simple. So in the beginning here, we can only take one action, which is to open an account. And so then immediately we get $500 or euros here into our bank account. And from there on, we can then take these different actions. For example, we can deposit some money. And so you see that now our balance went up by 150. But of course, if you want, you can later also use an input field and then deposit something else, which is not just 50. So we can withdraw money, of course, and we can request a loan. So then our account also goes up, and we see that our loan here also goes up. So that's the $5,000. But if we click here again, then that doesn't work again. So there can only be one active loan at a time. Then we can also pay the loan back at some point. So clicking here again, and finally, we can also close the account. But for that to work, there can be no loan and the balance needs to be at 0. So if I click now, that's not going to work. But if we withdraw all our money, then we can close the account. And so then basically it goes back to the initial state. So as always, I have all of this here in a starter file for you. So down here, I already wrote all the JSX. And this time I also wrote you some instructions or considerations that you can follow. So basically the rules that this bank account here should follow. All right, we also already have the initial state here, which you should use. And so you see we have the balance and the loan, which are these two. And then we have also the isActive state. So in the beginning, you see it's false. And so then all of these buttons here will be disabled. So right now, all the disabled here are just set to false, but you will probably then later use this isActive. And then here, of course, you will also write your own event handler functions. Okay, so hopefully this isn't too difficult. Just make sure to read these instructions here. And if you have any problem or any doubt, then you can just move on a bit in the video until you reach that part. Okay, so take a few minutes now to take this challenge to practice the very important use reducer hook on your own. Okay, so let's get to work here. And this time I will actually fork this so I don't overwrite the starter file. And so hopefully you did something similar to what I'm going to implement here now. So here we will have our reducer function and the initial state, of course. And so this will then return the state, which I will immediately destructure into balance, loan, and isActive. And we will also get the dispatch function like this. All right, next we need to create a reducer which takes in the current state and the action that was dispatched. Here we have some problem. And now let's do our typical switch here. So over action.type. And let's already create all our cases here at once. So we already know which ones they are. So we have open account, deposit, and all those other ones. So open account. For now, let's just return something here. Then deposit. Withdraw. And here, thanks to Prettier, we don't have to take any care of formatting this in any way. So request loan. Next up, we have pay loan. So that's not load, but loan. And finally, we also want the ability to close the account. And let's also, as always, add a default case where we just throw a new error like this. Okay. Now let's go back here to our JSX so we can use the variables that we got. So here we want to display the balance and here the loan. And so immediately we get our user interface there updated. And now here what we want to do, or first let's actually use also the is active instead of these falses. And actually here, of course, we want the buttons to be disabled when the account is not active. Except this one here, actually. So otherwise, we couldn't open an account in the first place. Okay, so here, what we are going to do to open the account is to dispatch an event with the type of open account. And we need to close this guy right here. And so let's see what should happen in this case. Well, as always, we will want to return our entire state object, and then the balance needs to be set to 500 because that is the initial amount. And then is active will be set to true. And so then all of these buttons here can get active. And so let's see. Yeah, nice. That's already working. And so let's keep going. So let's implement the next two as they are pretty similar. So the state and then the balance will simply be the current balance plus whatever comes in the action. So action dot payload. So again, the action payload is to pass in some data. And so here we are going to pass in 150. But of course, we don't want that 150 hard-coded right here in our reducer function. So we need to pass that in as the action. So then withdraw is just the same, but with a minus. And then here, yeah, let's try that. So dispatch with the type of deposit and a payload of 150. And as I was saying earlier, you could, of course, also created an input field here and then deposited the value that came from the input field. So you could have, or still can, go really crazy with this example here and make it a lot more complex and more complete if you want. So if you do that, make sure to post that into the Q&A because I would be really curious to see that. But anyway, as we click here now on this button, we each time deposit 150 into our bank account. And then here, let's just copy this whole line. No, actually, that's not really going to work. So never mind. So the type here is withdraw and then 50. And that works indeed. So these were the easier ones. Now let's take care of the harder ones. But actually, before we do that, we should do something else. So let's actually reload this whole thing here so that our balance is back to 500 and that our account is no longer open. And then here, or actually here, let's set it back to false. All right. And so now if I click here, then we can actually already deposit something in our account, even though it is not even active. And so we, of course, need to prevent that also inside our reducer function. We cannot rely only on the UI to block this kind of thing, because otherwise, at a later point, somewhere else in our application, we might dispatch an action like this, maybe not from a button, but from some effect, for example. And so we need to account for that case here in our reducer. So really blocking that action right here. So we can say if the account is not active, then just return the current state. So in this case, this wouldn't work. So this right here then wouldn't work anymore. So you see, it doesn't work. But what also doesn't work is to open the account then. And so we also then need to say if, or actually end. So if the account is not active and the action.type is different from open account, then simply return the state. And so that's the case right now. That's the case right now. So when I click here now, the account is not active and the type is not open account. And so then nothing works. But here, of course, the account is still not active, but the action type is actually open account. And so then this one here will not get executed and we can move on. And so then our account can actually get opened. All right. So these are some very important things that you need to keep in mind. And that's also the reason why it is so important to do these challenges, because it is impossible to cover all these things just in the projects themselves. So there are always some other edge cases like this, which can best be handled in more different situations. But anyway, let's now here dispatch some other action. So this one is to request the loan. So request loan. And here it is for 5,000 whatever, euros, dollars, some other currency, whatever. So let's see our instruction, what it says about the loan. So the customer can only request if there is no loan yet. And if that condition is met, then it will be added in the loan state and into the balance. All right. So let's again add a guard clause here, basically saying that if there is a loan already, so state.loan is equal than 0, then do nothing, which means to return the current state. So remember that this reducer function always needs to return some state. We cannot just return nothing. Let's actually see what happens if we do that. So we will experiment what that does next. But in the other case, so if there is no loan yet, then the loan should be equal to the action.payload. And of course, we first need the state itself. And then also the balance will be updated to state.balance plus our payload here. All right, so let's try that. So request a loan, and so beautiful. It was added to both of them. But now if I click again, then here we will get null as a return. And so that breaks our entire application, because now here, basically this object, so the state that was returned from useReducer is null. And so that cannot be. It always needs to be some state. So let's try that again. Yeah, so now it works. This one is of course not necessary. And so let's actually implement the next one here right away. So if the loan is paid, then it will go back to 0 and the balance will also go down. So it will go down to state.balance, balance like this. And then here, do you think that we need to pass in some value, so having like action.payload, well, that's not going to be necessary actually, because we already know what the loan was. So that's at state.loan. And so then that loan will simply be removed from the bank account. So let's dispatch that right here. So this is not like a loan in the real world, which we pay over a period of time. So it has to be paid all at once. So very simplified, as I said in the beginning. So pay loan. Now here we have some problem. And yeah, there it is. Now here we can click multiple times, and then we actually are not preventing this function here or this action from being called over and over again. But that will not do anything, because the second time we click, the loan will already be 0. And so then here, simply 0 gets subtracted from the current balance. So this is not going to be a problem at all. The only thing that you might think is a problem is that if we have here less money in the account than our loan, so then we have a negative balance, which in theory shouldn't be allowed, but well, in our bank it is allowed. The only thing that you can't do when you have a negative balance is to close your account. So I think that's what I say somewhere here. Yeah. So then the users or the customer can't close their account. Okay, and so speaking of closing, let's implement our last action here. And so this one says that the account can only be closed if there is no loan and if the balance is 0. And so let's do that right here. So actually we don't need this. We first need to check our conditions. And as always, we will do a guard clause, so one that returns the state in case our conditions are not met. So if the loan is greater than 0, and if there is a balance right now, so if the balance is different from 0, then once again, just return the state. But otherwise, then we want to close the account, and so then it is no longer active. And so basically what we have then is the initial state. So no balance, no loan, and the account is not active. So just to finish, we need to now dispatch that action here. So type close account. So let's see. Well, that's some problem right there, because we shouldn't be allowed to close our account with the balance that we had before in negative. So let's see what we did here wrong. And here it should be an or. So not an and, of course, at the same time. So if there is a loan or if there is some balance, then we just want to do nothing. So that's just returning the state. And so this means that if there is no loan and if the balance is 0, then we can return the initial state and the account is closed. So let's try that again. Open the account, and now I cannot close it. Let's withdraw a bunch of money. That was too much. So now I can also not close. But yeah, now that works. Amazing. So that actually finishes it. And now, as I said before, you can just go a bit crazy here if you want with this exercise and maybe add some more operations here or include some input fields or really do anything that you want. You can also use an account number like we did in that analogy. And if you do any of that, then just make sure to show it to me so I can see your progress in the Q&A. And also, if you want more use reducer challenges like this, because maybe you still find it a little bit difficult, then also let me know in the Q&A section. And with that being said, let's now move on right to our next section where we are going to use for the first time an external library. And that is React Router, so that we can build our very first real single page application.